Good morning, good afternoon, good evening to all chemistry learners and my chemistry students all over the world, the e-learning students and everyone watching this video right now, and to you particular watching this video. If this is your first time of watching my video, I am your chemistry tutor. Akpeji Honesty is my name. Okay, you are required to if you like the video, if you find the video interesting, rather, you can show some likes, and also subscribe to the YouTube channel, and then share to others so that they can view and gain same experience, same knowledge, same understanding about chemistry, so that those who have been having issues with chemistry, they will find it very easy and also very interesting. Look at it. This is a question before us again: to calculate the most probable speed, arithmetic mean speed, and root mean square for hydrogen molecule at 0 degree C. Okay, we shall be doing that. Please, when you are solving question, it is good you bring out the units in the formula so that you can be able to cancel the units out and cancel identical species, so that you have a standard unit that you will be having as your final answer. Let's go straight to the most probable speed. Okay, the most probable speed is given by this formula throughout T over capital letter M, which is the molecular weight, okay, to the square root of that, or you bracket it raised to the power of half. Do you understand? You bracket it like this, or we remove this square root, then bracket it raised to the power of half. Okay, now let's look at what are the things given. We are only given temperature, and temperature to be 0 degrees C, which is 273 Kelvin. And also there's hydrogen molecule. So for hydrogen molecule, hydrogen is 1. Okay, so that will now give you 1 times 2. 1 times 2 will be equal to 2 gram per mole. Understand this is in gram per mole. Then our R is 8.314, which is in actually it is in joule, okay, per joule per mole, then per Kelvin. Okay, per Kelvin. Okay, but if you look at, this is gram, this is joule. Okay, and you know that 1 joule is equal to 1 kilogram meter per second square. That means I can put this kilogram meter per second and put it here. Okay, just for a learner to understand, so that I can say R is equal to 8.314 kilogram meter per second square. Okay, then I will be having mole per mole, then per Kelvin. Okay, the reason why I'm doing this is that this is gram. Okay, so that you will now be seeing the kilogram coming out now, so that there is a need for us to either convert this one to gram or convert this one to kilogram. That is what I mean. Okay, I can also say, that 1 joule is equal to 1 kilo 1 joule, no, is equal to 1 Newton meter. This is what I'm 1 Newton meter, okay, is equal to 1 joule, okay, is equal to 1 joule. Okay, this is not correct. Let me remove this. Okay, let me remove this. So what I mean is 1 Newton meter is equal to 1 joule. Okay, and it means that I can now, please understand, do not be confused, it means that I can now use this my R and say 8.314. In place of this joule, I'll put Newton meter. Okay, that means I'm saying R is equal to 8.314. In the place of this joule, I'll put Newton meter, then mole per mole per Kelvin. And you know that 1 Newton 1 Newton is equal to what now? 1 kilogram meter per second square. Okay, so that is to say, in the place of this Newton now, in the place of this Newton, I can put this unit. Okay, so that is what I'm saying here. In the place of this Newton, look at me. Oh, in the place of this Newton, I say 8.314. This is Newton. In place of this, what am I putting? Kilogram meter per second square. This is it. Then meter, this is my meter still remaining. So if I am to rewrite, I'm going to be having 8.314. Okay, in place of Newton, I am putting what? Kilogram meter per second square. Then this is my meter, then mole per mole per Kelvin. I am doing this so that the unit of kilogram will come out with respect to the gram given as the molecular weight of hydrogen. Okay, so it is good you give these details in case of examination or when you are teaching people, so that student or a new learner will understand what you are trying to do. So in that case, I have my R in the standard unit, I have my T in the standard unit, I have hydrogen, molecular weight of hydrogen in gram per mole. So it will require me to convert it to kilogram per mole, or I convert this one to gram, okay, meter per second square. If you do any of them, you will, if you are converting this one to gram meter per second square, you see, you'll be multiplying by 1000 here. Okay, meanwhile, the reverse is the case here. So let me take my molecular weight of hydrogen, which is what? 2 gram per mole, okay, will now be equal to 1 gram is equal to 0.001 kilogram. Okay, so having known that, that is to say, I will now say 2 gram will be equal to the molecular weight of my hydrogen, which I will calculate out by cross multiplying this times this to give me molecular weight of hydrogen is equal to 2 times 0.001. Okay, okay, so I will be having it to be 0.002. This, in this case, it will not be in kilogram per mole. Okay, in kilogram per mole. So you have calculated, you have now known this. Before we start substituting, you need to, it is good you put all these things, you do all these things well before you start substituting. So in that case, you have your most probable speed is equal to the square root of 2 times 8.314. Look at me. What am I putting here? I am using kilogram meter per second squared. Okay, then dot meter dot per mole per Kelvin. I'm doing this so that you will know how to cancel an identical unit, times temperature, which is what? 273. Okay, Kelvin. Just watch it, you are going to see 273 Kelvin. Okay, as it is like this, you divide it by what now? The molecular weight, which is, we have it at 0.002 kilogram per mole. Do you understand? So in that case, you can see this per mole will cancel out this kilogram will cancel out this Kelvin, and this Kelvin will cancel out per Kelvin. Okay, so you will be left with Cp is equal to, if you calculate this times this times this divided by this, you are going to have, 2269722. So if you find the square root, you will have 1506 meter per second. Before I put this meter per second, let's analyze how it is the meter per second. You know what you have left here is meter second, then meter, then per second square, then you have meter remaining all squared. So as it is all squared, that means raised to the power of half. That means you will be having m raised to power 2, okay, then x raised to power minus 2 times this raised to power 2, then m raised to the power of 2. You just like you are using this power to expand the bracket. So this and this are the same, bring them together, m raised to power half times m raised to power half, then this one times x raised to power minus 2 times half. This already tells you that they are the same. You can pick one. If you solve in indices, you're going to have 1. Half plus half will give you 1. Then x, remaining x here, this will cancel, remain raised to power minus 1, which is meter per second. So that means your answer will now be 1506 meter per second. Do you understand? So the same thing you do for your arithmetic mean. Let's calculate our arithmetic mean. What will it give to us? Remember, our arithmetic mean is given this formula, which is 8RT divided by pi m, okay, in e square root, or 8RT divided by pi m all raised to the power of half. Is the same thing, okay? It's exactly the same thing you will be doing here. Here you have 8 times what is our 8.314, okay? Then we have it as a kilogram meter per second square, then meter, then you have per mole, then per Kelvin, then times our temperature 273 Kelvin, okay, all divided, remember it is all in square root. Pi is 3.142 times our molecular weight, which we have done in kilogram per mole. Where is it? Kilogram per mole, you have 0.002, okay. If you divide and solve, you will be having the square root of 2889525.143, okay, which will give you 1699, okay, or 1601, because it's 1699.8, which is equivalent to 1. If you approximate this, or except you want to leave it at 1699.9, okay, but normally if you want to approximate this one will turn to 1, then this one will turn to 1, this one will now be 1700 meter per second. Okay, how you got meter per second also is from the same manipulation here. So I give you as that as assignment. Okay, you do the same thing. This one is kilogram, okay, per mole. So if this cancel out this, okay, and this cancel out this, you will be left with just this will cancel out this, you will be left with this and this, okay. And if you take the raised to the power of half, as in this case, you will still come back to meet this unit, okay. Then the last one is the root mean square value for hydrogen, okay. So for root mean square value for hydrogen, you have formula of 3RT over the molecular weight. So this will still give you 3 times 8.314, okay, in kilogram meter per second square meter then per mole per Kelvin times temperature, which gives you 273 Kelvin, all divided by the molecular weight, which is 0.002 kilogram, okay, per mole. Remember, this will cancel this will cancel this. I will have Kelvin will cancel per Kelvin. Per Kelvin is like this, 1 over Kelvin times Kelvin, so it will cancel. Okay, so I have what is left. If you manipulate it out the same way, you are going to have meter per second. Okay, you are going to be having meter per second. So let me do it. Okay, maybe you will understand better here. This, you have this left, meter per second square, then times meter. Remember, it has a square root, and this square root, if you remove this square root, it will now be raised to power half. So if you solve this, you have m raised to power half times x raised to power minus 2 times raised to power half times m raised to power half. So you bring this together in indices, m raised to power half times m raised to power half. Remember, it's meter, okay, times x raised to power minus 2 times raised to power half will give you this. You pick 1 in indices, m raised to the power of 1 over 2 plus 1 over 2, then times x. This will cancel this remaining raised to power minus 1. So if you solve this, half plus half will give you 1, okay, then s raised to power minus 1, which is 1 meter per second. You see, they are the same. So if you solve now, you have the square root of 3404583. Okay, when you find the square root, you will be having 1845 meter per second. Okay, I hope you understand that. Okay, so if you do, share with others and to encourage them in the knowledge of chemistry. Thank you. I remain your tutor, chemistry tutor, Akpeji Honesty. Follow me up on my YouTube channel by subscribing to it. You put on the your notification button. Whenever a new video is uploaded, you will be duly notified. Bye.